Hi, in this video I'll be discussing completing the square in a geometric point of view. This will form the basis of the proof of the quadratic formula and allow you to understand the topic in a more intuitive way. Let's go. First of all, I take an algebraic expression which is not a perfect square yet. Say x squared plus 4x plus we don't know what this term is. Actually, we will complete this algebraic expression to a square. Let's see what's going on. Okay, let's start with a square. Yes. And then let's duplicate this and make it larger. You know why I'm doing this? Because I am adding something to a square. Say the side length of this square is x. Okay, and since I add something to it, I make a larger square. But did you notice something? If I pick this square and play with it, let's say they are the same size. They are the same size now. And when I'm taking this corner, you see this line, this side and this side, they move in parallel. They are equal to each other. Okay, I will do it one more time and you can see it clearly. Okay, now they are the same size, and now you see they are both getting larger and they are equal to each other. You know why? You can see easily that in order to make a square, I have to add the same length to both sides. You see? So let's leave it here. Okay. Now I have equal sides. Well, that being, if I say there is a small rectangle here, and let's call it top rectangle, and if I have a rectangle here, let's call it right rectangle. These rectangles are congruent and they totally have the same length. So if I say this area equals to x squared, now these parts, let me paint them. These parts, this rectangle and this rectangle, they form the middle term of my algebraic expression. Since these rectangles are the same and they add up to 4x, the area of each rectangle is 2x. That means since this side length is x, this side length has to be 2 in order to make 2x. And since this side length is x, this side length has to be 2. Great. But wait, this 2 actually tells me the side length of this very small square. If I add this small square too, now I will have a larger square. Let's paint it to a different color. Like this. Okay, this is the last term of my algebraic expression and I'm about to find it. After finding it, I can safely say that this expression equals to, you see, side length of the larger square, it's x plus 2, square of x plus 2. But what is the area of the square? Well, we're about to find out, because since this side length is 2, this will be 2, and the same is true for this side. So the area is 2 times 2 equals 4. So if I add 4 here, now I can safely say that I have a perfect square. And this is called an identity of sum, actually, a square of sum. Okay, well, that's about it. Let's make one more example, but this time I will make this coefficient an odd number just to get familiar with rational numbers and just to show you that nothing really changes. It's just a number. Okay. Okay. Let's start with x squared again and add 5x this time. And what shall I add to that in order to make this a perfect square? Okay. We'll find out. Let's start with our square first. Okay. And duplicate it. They are same size now, but since here you can see I'm adding something to it, so it means I will have a larger square, right? So I have to make one square larger, you see? Now it's getting large because 5x is added to it and something else will be added to it and it will become a square. Okay. Let's leave it that way. Now, this part, the side length of this square is x. So the area of the inner square is x squared. Okay, let's color code this one. This x squared belongs here. Okay, now I'll have my rectangles here. The upper rectangle, the rectangle on the right. Okay, the sum of these rectangles equals to 5x. So the area of one rectangle is the half of this thing. Well, in the previous question, we had an even coefficient like 4 and half of it makes 2. But this time we have 5 and half of it is going to be 5 over 2, right? Okay, so this is 5x over 2. The side length of this rectangle, the longer side is x, so this side has to be 5 over 2 and same here. You see, this is 5x over 2 and if I add them, you know what I get? 10x over 2 which equals to 5x, this part. So let's color code this part now. Let's put green here. Okay, this is the sum of green parts. Now, if I add a perfect square here, I mean this little square, now I will have my perfect square. Okay, well actually I can find out what I am going to add because this part is 5 over 2, which is also the side length of the square. You can see the same thing through this perspective. Okay, and the area is going to be square of 5 over 2, and that is 25 over 4. So I know what I'm going to put here now, 25 over 4. As you can see, we can complete to a square. Let's pick a different color for this. Okay, now this is this part. When I add it, I have my perfect square. Great. By now, there's a pattern emerging and you should realize it. What's that? Let's check it out. In the middle term, this middle term comes from the rectangles and there are two rectangles. In order to find the area of one rectangle, I divide this middle term by 2. There you go. That's 2x. And then in order to find this short side length of the rectangle, I divide it by x. And then find the short length of the rectangle, which equals to the side length of the smallest square. And then, oh, sorry, I made a mistake here. I should divide 2x by x, and then it equals to 2, right? Okay. And so I square it and find the area of the little square. Great. Let's proceed to the next one. Here, the same thing. The middle term is 5x. Since this 5x is provided by two rectangles, I divide it by 2. Okay. And since the side length of this longer side length of rectangle is x, I divide it by x in order to find this shorter side length. These cancel out and it's 5/2. And in the end, I take square of it in order to find the area of the little square. So that's the pattern. Good to know. Now we'll do something different, but in another video. In this video, we did this identity of the square of sum, and in the next video, we'll do the square of difference. See you in the next video.